According to statistics, grassland makes up nearly 60% of Ireland's landscape, forming the backbone of our agriculture. In this video, we explore how that familiar green landscape is being reimagined through Ireland's first grass biorefinery and Farm Zero C, a bold new model of climate-smart farming. This story is brought to you by BBioNets.
My name is Padraig Walsh. I'm the project manager at Farm Zero C, working for EIP-AGRI Group. Farm Zero C is a collaborative project co-led by EIP-AGRI Group and Biorefinery, looking at creating a climate neutral system here at Shannock Estates Dairy Farm based in Banton in West Cork. As part of the project, we like to use a holistic approach, so we're looking at the farm as a whole. The carbon footprint is a big part of what we're looking at, so as part of this project we're trying to create an economically viable climate neutral system on this farm. So that means we still want to maintain profitability on this farm. We like to use a holistic approach. That means we're looking at every area of the farm, but we also have a big focus as well on the biodiversity here in the farm as well, so trying to improve the quantity and the quality of the natural habitats that we have here in the farm. Also looking at water and air quality as well, so trying to reduce nitrates or nitrate losses coming from the soils, and trying to reduce ammonia emissions coming from the farm then as well. We've a couple of key pillars as part of the project as well, and some key focus areas for us to try and reduce our carbon footprint. The first of these is what we're trying to look at is trying to reduce our chemical fertilizer use here on the farm. So trying to incorporate stuff like white clover and red clover and multi-species swards onto the farm here as well. White clover works as a nitrogen fixator, so what that does is it actually pulls the nitrogen from the atmosphere and makes it available for grass to grow, which enables us here in the farm to actually reduce our chemical fertilizer input here. We also have multi-species swards as well in the farm. What they do is they help to improve soil structure. So they've got deeper tap roots, they've got a wider root network as well, so they create more aeration in the soil. They're able to put up more water nutrients as well, which are available to the grass to grow as well. So we've been using multi-species swards and white clover over the last number of years here in the farm as well. We've reduced our chemical fertilizer input by approximately 40%. We're trying to reduce the amount of imported soya that we use here in the farm, so we've actually replaced imported soya in our concentrate mix with native Irish beans as well. So those beans are an alternative protein source grown in Ireland, which are a lot lower carbon footprint than imported soya, which would be coming from South America as well. We're also trying to reduce the emissions which are coming from our slurry as well. So we're storing slurry here for when cows are housed in the winter time. So cows are normally housed around November time and are let out to grass, depending on weather, from end of February into March then as well. While they're indoors, they're obviously creating slurry as well, which is a source of emissions for a dairy farm. It's approximately 10% of emissions on an average Irish dairy farm is coming from the stored slurry there. So we're working with an Irish company called Glasport Bio. They're based up in Galway. They have a slurry additive which is called gas abate. And what this does is it acts as an inhibitor for the slurry, so it stops the slurry or the bacteria in the slurry from breaking it down and releasing stuff like ammonia and methane into the atmosphere as well. So we have that system actually on the farm now as well in the last couple of years, so that's helping us to reduce our emissions which are coming from our stored slurries here as well. Another thing we're trying to do here is we're trying to measure soil carbon sequestration. So we know that soil is removing carbon from the atmosphere and storing it there. We're actually trying to quantify that and measure it, so we can see how much carbon we're actually removing and storing in our soils as well. So we are working with an Irish company called Senis who are doing this work for us as well. They're based up in Athlone, and what they've done is they've taken soil carbon stocks of the farm here on every paddock. They've also done it for the 10 monitor farms which we're working with as well, who are all EIP suppliers based around West Cork. Baseline these soils in 2023, we'll measure again in 2026 as well. So I know another way that we can improve the amount of carbon that we're sequestering as well is by improving our soil health. So we're looking at the soil health work package as well.
My name is Mary Kate Doherty. I'm a PhD student with UCD, and I'm doing my trial work here on Shannock Farm, where the Farm Zero C project takes place. So my PhD research focuses on soil invertebrates like earthworms, springtails and mites, and how they interact and cycle nitrogen through the soil. So there's a lot we don't understand about the soil, and especially soil animals, and we know a lot about how the microbiome cycles nitrogen through the soil and up to plants and grass, But the role of soil animals in soil nutrient cycles isn't very well studied, and it can be very important to how farmers manage their soil. So I'm looking into how different agricultural practices such as multi-species swards or clover incorporation affect the soil animals and their processes in the soil. So hopefully this can help farmers manage their soils in a more sustainable way and help deal with the weather patterns we're getting in recent years, such as drought or flooding as well.
The most recent innovation we have at the moment is we're working on our integrated grass biorefinery unit that we're working in collaboration with James Gaffey from MTU with. That unit we have planning permission for now, and we're hoping to construct that towards the end of the summer in 2025 and hoping to be operational in 2026.
A grass biorefinery is a processing facility which takes in grass and can produce different products from it in sustainable manner, so using sustainable technologies. The reason why it's interesting for Ireland is that we have the largest volume of grassland in Europe in terms of total land area devoted to grassland, which is over 50% of our total land area. From an Irish point of view, it's a huge national resource. And what a grass biorefinery can do is allow us to extract different products, creating some products for cows, some feed products for cows, which we normally feed grass to cows anyway in Ireland, but allowing us to create new co-products from that grass, products like an animal feed, products like energy, and potentially high-value products as well. Biorefinery Glas, as you mentioned, it was EIP-AGRI funded. So it was a mechanism which allowed farmers to come together with researchers like me, with companies and other actors in order to implement innovations associated with sustainable agriculture. So the Biorefinery Glas project ran from 2019 to 2021, and the focus was on implementing a small-scale mobile grass biorefinery in regions in West Cork, and that was done in collaboration between MTU, UCD, Carberry Group on the dairy farmer side, Barry Rowe Co-op on the pig farm side, and also Grassa, a technology provider in biorefinery from the Netherlands. So the project then allowed us to really test if a biorefinery would actually work from an Irish perspective, to evaluate the products that was going to produce. So we set up a lot of different feeding trials to evaluate products, to do some lab analysis as well on some of the different additional co-products and high-value ingredients, and to also try and improve the farmer awareness of the technology as well. And then we have some EU projects as well, which are overlapping with this, such as the Rural Biorefineries project, which is going to be looking at really stretching in terms of innovation associated with grass biorefinery. And that's going to look at different types of feedstocks we can use, but also what are some of the different types of high value ingredients and products that we can build around this. So we're looking at animal feed, we're looking at cattle feed and pig feed associated that we can produce. We're looking at energy production, but we're also looking at a lot of high value ingredients. For example, producing food grade protein, which is high in value, producing all kinds of different flavor ingredients, antimicrobial ingredients, so functional ingredients that can have a lot of value to the overall grass production. The grass biorefinery approach can be beneficial to the farmers because they get to keep some of the grass to feed to their cows, but they're extracting out a juice, and from that juice in the biorefinery, we can produce a pig feed from it. We call it a protein concentrate, which can replace soy. So in that way, we can connect through improved resource efficiency. We can connect our grassland farms to our pig farms, creating indigenous protein supply for those pig farms, displacing soybean meal, which has a very high environmental footprint, both in terms of transport and in terms of things like deforestation associated with soybean production. Instead, we can create a grass-based alternative which can improve the sustainability of those concentrates, but it also creates resilience for those farmers as well, because we're less reliant on imported soy. We also create a revenue opportunity for the dairy farmers who could sell that protein to the big pig farmers. We're also potentially creating energy from the process, which can be supplied and help to meet Ireland's renewable energy targets and the big bioenergy and biomethane target, which is 5.7 terawatts of electricity. And then also, in addition to this, we can produce all of these high value ingredients, which we're now starting to explore. And from, we'd say, an Irish agricultural point of view, there's always been innovation in agriculture. Farms have always been looking at how they can improve the value of what they're producing. So I think the biorefinery fits very well in terms of creating those future opportunities for Irish agricultural grassland farmers, dairy farmers, beef farmers to actually increase those revenue streams, but also displacing products like fossil fuels, like soybean imports, which have a high carbon footprint, and in that way can also reduce the national footprint from agriculture as well.
So there's some of the stuff on the farm here which actually could help us to save money. So, you know, there is stuff like white clover as well, which we are reducing our chemical fertilizer input, and there's obviously a cost associated with that. So, you know, if we can maintain, you know, the levels of grass growth that we have while reducing chemical fertilizer, that would be a cost saving for the farm. Now this can be challenging as well, especially with the weather conditions that we've seen over the last few years. Other stuff we're doing as well, I suppose the chemical slurry additive, or the gas-based system slurry additive that we have here on farm at the moment, there is a cost associated with that as well. At the moment, probably there isn't a mechanism to pay for that for a farmer, but that is something that we're working on as well. We're looking at running a pilot with the 10 monitor farmers and another project as well, which is looking at actually scaling these technologies out in farm. Probably will need some sort of combination of industry and government coming together to help farmers to implement these technologies on their farms. At the end of the day, farmers are running businesses. They need to maintain their profitability as well. So, you know, farmers are quite willing to try and reduce their carbon footprints, but their efforts need to be rewarded for that as well.